Today's lesson is called Multiplying and Factoring Polynomial Expressions, Day 2. For the opening exercise, it says multiply the two binomials. After multiplying, answer the two follow-up questions below. So when you get to the word examples, you want to stop. That's where we will move on together. At this time, please pause the video, try the practice problems in the opening exercise, and resume when you're ready to go over the answers. Okay, now that you've completed the opening exercise, let's go over the answers. In number 1, I showed, and in number 2, the arrows that you would use if you wanted to use the distributive property. So you would still get x squared, then you would do x times negative 4 is negative 4x, then you would do 3 times x is 3x, and 3 times negative 4 is negative 12. But I also wanted to show you the boxes, so that's why you see the boxes underneath, showing that the like terms land on the diagonal. So in number 1, you should get x squared minus x minus 12. And then when you look at number 2, you should get x squared minus 16. So the first follow-up question says, what is different about the two products? Well, the first results in a trinomial. So remember, a trinomial is a 3-term polynomial. So looking up here, 1, 2, 3 terms. Whereas the second results in a binomial, which is a 2-term polynomial, 1, 2. So when do you think this will occur again? This is only going to happen when you end up with opposites. So to get a binomial, the middle terms must be opposites of each other. So for example, negative 5x and positive 5x. If we look at number 2, we had a negative 4x and a positive 4x. That's how we ended up with 0 for the middle term where it cancels out, and you end up with only x squared minus 16. So now let's kind of take a look closer at the setup of that. Why did that happen? Well, if I look back up here at number 2, x and x are the same, 4 and 4 are the same, and we're in a situation where 1 is a plus and 1 is a minus. That's how I know that's going to happen. So when we look at some examples that we could write down, it would be things like x plus 6 and x minus 6. There's an example. We could use variables. So x plus y, x minus y, still going to work. Let's throw in some fractions. So a plus 1/2 and a minus 1/2 would be an example. We could also have an example like 6y minus 3 times 6y plus 3. So it doesn't have to be just a single variable in the first position. It's okay that it's 6y, or let's say y squared, or anything. So the general form of this that you're seeing is that you're going to have a plus b and then a minus b, and that's always going to give you a squared minus b squared because those middle terms will fall out. So put a box around that. That's our general form. So right now, I'd like you to pause the video and circle all of the following products that would result in a binomial. When you're ready to check your answers, resume the video. Okay, now that you've had time to circle all of the following products that would result in a binomial, let's go over the answers. You can see the ones that I circled. The ones that I crossed out are a problem because I don't have the pattern that I'm looking for. A plus b, a minus b. A plus 3, a minus 3 works because we have plus 3 and minus 3. M minus 0.9 and M plus 0.9 works because we have opposites, negative 0.9 and positive 0.9. R minus 8 times R plus 8 again works because we have the negative 8 and the positive 8. And at first glance, it might look like the bottom right corner doesn't work, but you can rearrange these. So negative 4 plus n squared is the same thing as n squared minus 4. So if I change that to n squared minus 4 and n squared plus 4, it looks more like what we're used to in our general form, and therefore you should have circled that binomial multiplication. So what are we getting at here? Well, the sum of two middle terms of the product is 0. Therefore, the product is a binomial and not a trinomial. This is called the difference of two perfect squares, which we will refer to as dots. When this happens, I want to show you how you can factor quickly as soon as you recognize that it's a dot problem. Okay, underneath, I would like you to write to take the square root of A and B. And then I'll put then opposite signs. So what do I mean by that? Okay, let's look at example number 1. First, I have to make sure that it qualifies as a dots problem. Is it a difference of two squares? Well, 81 is a perfect square. And when it comes to looking at variables to figure out if they're a perfect square, you're looking for even. So I'm going to point here and write even. So perfect square. So I know if it's a dot problem now, because it satisfied the criteria, that this is going to get broken down into two binomials. The square root of p to the fourth is going to be chopping that in half, dividing it in two, and making it p squared. So p squared goes in the first position in both. Then the square root of 81 is 9. So 9 goes in the second position. And then we just need to make sure we make one a plus and one a minus. It doesn't matter which one. So this is my factored form of p to the fourth minus 81 using dots or difference of two perfect squares. Let's look at 49x squared minus 36. So first we have to make sure it qualifies as a dot problem. 49 is a perfect square, x squared is a perfect square because the exponent is even. 36 is a perfect square. So we do have a dots problem. So we're going to know then that we're going to split this into two binomials, and we're going to take the square root of each piece. The square root of 49 is 7, and the square root of x squared is x. So 7x is going in the first position in both. The square root of 36 is 6. And then we know we need one plus and one minus. So this time I'll put the minus first and the plus second, just to show you that it does not matter. Now at this time, if your teacher has left another practice activity, you are done with the video and you can go complete your other practice. If they would like you to complete the practice in your notes, please pause the video and then resume when ready to go over the answers. Okay, so you've had a chance to try the practice. Let's go over the answers. T squared is a perfect square. 25 is a perfect square. So the square root of t squared is t. The square root of 25 is 5. Make sure to make one plus and one minus. In letter B, 4x squared and 9 are perfect squares. The square root of 4x squared would be 2x. The square root of 9 would be 3. 1 is plus, 1 is minus. In C, 16h squared, the square root would be 4h. 36k squared, the square root would be 6k. 1 plus, 1 minus. In D, 4 is a perfect square. The square root of 4 is 2. B squared is a perfect square. The square root of b squared is b. So 2 plus b, 2 minus b. In E, the square root of x to the fourth would be x squared. The square root of 4 is 2. So we have x squared plus 2 and x squared minus 2. And then lastly in F, x to the sixth is a perfect square. Remember, we're looking for even exponent numbers. The square root would be x to the third. 25 is a perfect square. The square root of 25 is 5. So you end up with x cubed plus 5 and x cubed minus 5. And that concludes your lesson on multiplying and factoring polynomial expressions day 2, which deals with difference of two perfect squares.